Thanks, Ben. As mentioned earlier, I'll be looking at the diet of the other main Sauropterygian groups, the Pistosaurids and the Pachypleurosaurs. Pistosauroidea is a large and diverse group of marine reptiles that evolved around 250 million years ago and remained until the KPG extinction event 66 million years ago. The exact phylogeny of the group is often debated, but the general features remain the same. Plesiosauria is the largest and arguably most significant group within Pistosauroidea. Plesiosaurids emerged around 203 million years ago. They are characterized by wide, flat bodies, a short tail, and four large, powerful flippers. However, the heads and necks of species within the group vary between two main morphologies: the plesiosauromorphs, which had small heads and long, thin necks, and the pliosauromorphs, which featured large heads and short, stocky necks. Evidence for the diets of extinct animals can generally be sorted into three main groups: direct, indirect, and general. Direct evidence refers to that which is nearly indisputable, in particular bromeliads, which are pieces of preserved organic matter originating from the digestive system of fossilized specimens. A number of pistosaurid fossils with recognizable guts have been unearthed and analyzed. Cephalopods and other mollusks make up the majority of the digestive remains found, usually in the form of hooklets, shell pieces, or jaw fragments. Other remains found in fossilized guts include fish scales and reptile teeth. The bromeliads found suggest pistosaurs had a diet consisting mainly of various cephalopods, supplemented by fish and smaller marine reptiles, though factors such as seasonality make exact reconstructions difficult. Indirect evidence consists of that which, while potentially useful, is not irrefutable or may have another explanation. For instance, pistosaurid fossils have been found containing gastroliths in their guts. These are small stones purposely consumed by animals, but their exact purpose can vary. They may have been used to aid in mechanical digestion, providing a hint of the type of prey they consumed, but there is also the possibility they consumed gastroliths for the sake of buoyancy. Other pieces of indirect evidence include plesiosaur bite marks found on the bones of other animals, and coprolites, which are fossilized feces. Finally, general evidence refers to inferences made by analyzing the anatomy and morphology of fossilized specimens, often by comparing them to modern analogues. Pistosaurids have strong triangular skulls with deeply set teeth and an expanded mandibular symphysis, which is the point where the lower jaw fused. Together, these features suggest that pistosaurids were prepared for securing a grip on large prey or carcasses and then ripping off flesh through twist feeding, like that observed in modern crocodiles. Additionally, many pistosaurids have backwards curving teeth, indicating that they trapped prey in their mouths. Pistosaurid skulls bear some resemblance to skulls of modern animals, for example, the orca. From these pictures, multiple similarities can be observed, such as the wedge-shaped skull, the closely packed, deeply rooted teeth, and the large jaws. All these pieces of evidence seem to paint a wide picture, suggesting that pistosaurids potentially consumed a broad variety of prey, from small fish and cephalopods to other marine reptiles and possibly carcasses. Pachypleurosauroidea is generally considered to be a sister group to Eusauropterygia, the group that includes both the pistosauroids and the nothosaurids. Potentially owing to their small size, little evidence in the way of pachypleurosaur diet has been discovered. However, some insights can still be made. Fish scales have been identified in the bromelites of fossilized specimens, and their teeth are peg-shaped and recurved, suggesting they were adapted to hunting small fish. Some specimens display an unusually large gastrointestinal region, perhaps indicating that they were capable of storing excess food as a reserve. Overall, Sauropterygian species display a wide variety of diets and feeding mechanisms, from decapods to fish, and from active predation to scavenging. From Ben and I, thank you for watching.